In November of 2021, the United Nations Climate Change Conference was held in Glasgow, Scotland. Parties from all over the world descended on the conference with the goal of tackling climate change. Pledges were made, agreements signed, but is it enough? Can the world avoid global warming of 1.5 degrees? All of this and more on today's episode of The Secret Life of Numbers.
Welcome to the Secret Life of Numbers podcast, the podcast where we dissect everyday numbers and statistics to find the stories behind them.
Each episode, we take a number or statistic and break it down. We will tell you where it comes from and what it means for you. Along the way, hopefully we will inspire you to think about the numbers in your own life.
I'm Levannia, your data scientist on call. I'll be breaking down the numbers.
I'm Lindsay, your data translator. For when Levannia gets too technical on us, I'll be breaking down the rest.
All right, let's jump in. I guess today is very fitting for what we're talking about because we're recording on April 22nd, which is Earth Day.
Yes, it is very fitting and kind of serendipitous because I think we were actually supposed to record this episode on a different day, but schedules got moved around.
Yes, it was meant to be.
Yes.
I think we've talked about climate change. Like in season 2, we dedicated 3 episodes to this topic, but we didn't really talk about why 1.5 degrees mattered or why this was what we were working towards.
Yeah, and I think it opens up an interesting question of what is the world going to look like at 1.5 degrees? And are we actually able to even meet the 1.5 degrees target? We'll get into it, but it's not a certainty that we'll be able to keep global warming to 1.5 degrees.
Let's jump into some numbers.
Yes, let's do it.
For the numbers section, I thought I would first define weather and then climate. And then we can get into like the nitty-gritty of how we actually monitor the Earth's temperature.
That's super interesting because we hear these terms thrown around all the time, and it's nice to actually have a definition.
So for these definitions of weather and climate, I turned to NASA because I feel like they wouldn't do me dirty. Or I feel like they're a reliable source in terms of what climate and weather are.
Absolutely.
So they say that the difference between weather and climate is really just in the measurement of time. So weather is the conditions of the atmosphere over a short period of time, and climate is how the atmosphere behaves over a relatively long period of time. Your weather could be like what's happening today or this month. Today, it's rainy for me and it's a bit cloudy. It's overcast. It's 4 degrees. But the climate is over many years, I've noticed that the city in which I live has become warmer.
Right. So it's that time frame that really differentiates.
Yeah.
Got it. As the weather changes and temperature changes, how are we measuring that to get a sense of how the climate is changing?
That's a really good question because as the weather changes day by day, that adds up to your climate and you would want to monitor it in some way. So the way we're actually monitoring the temperature of the Earth is using a method called the GIS temp or the GIS temp, and this stands for the Goddard Institute for Space Studies Surface Temperature Analysis. I'll go through like a Cliff's Notes version of how we actually come to the temperature of the Earth.
Right, because this is something that's also changed a lot over time in terms of our ability to measure and our kind of awareness of where we should be measuring temperature.
In the late 1970s, scientists at the Goddard Institute of Space Studies, they realized that they needed to start monitoring the temperature of the Earth because the Industrial Revolution was happening, all of the CO2 was going into the atmosphere. And at that time, there weren't a lot of monitoring stations that monitored temperature across the Earth, right? Because you can imagine that in order to measure temperature of the entire Earth's surface, you need reliable measurement systems everywhere across the Earth's surface.
Yes.
So the very first publications about the temperature were really only focused on the northern hemisphere. So in 1987, we refined the procedure published by James Hansen, who was working at the Goddard Institute for Space Studies, and we now use that procedure with a few more refinements today.
Okay, so where do we measure temperature?
Okay, so we're going to go on a journey.
A journey around the world?
So you can imagine if you need to reliably measure temperature all over the world, you need to first divide the world into spaces.
Right.
There's like some management that you need to do up front. So the way that this system of calculating temperature works is they divide the world into 80 boxes, and these boxes have equal area.
Okay.
I put a picture of this division in our outline for you, Lindsay. For funsies, which box are you in?
Which box am I in? I am in box number 6, I think.
I think I'm in box number 7.
Aw, we're side by side.
We're side by side. We are. Once you have these 80 boxes, you then divide each of the 80 boxes into 100 boxes. So you're ending up dividing the entire Earth's surface into 8,000 boxes.
That's a lot of boxes.
It is a lot, but the Earth is a large place and temperature is affected by many things. So I can imagine that you want to have as much data as possible to accurately represent the temperature that you're going to collect.
Right. So in each of these 8,000 boxes, is there a separate instrument that measures temperature? How do they do that?
So if we look at the major boxes that form up the 80, what they're going to calculate is a weighted average of the temperature in that box. So they consider the center of the box. They're using what's called a radial bias function to determine the weight. So if there's a meteorological station monitoring the temperature within that box, the further it is from the center of the box, it will have less weight in determining the temperature of that box. And if you're like located right in the center of the box, then you're going to have the most weight in determining the temperature.
Right, because I guess that would be the most true since it's the furthest away from all the other boxes.
Yes.
Whereas at the edges,
you might be seeing like effects from other boxes.
Exactly. Okay, that makes sense.
Once you have this like weighted average of your sub-boxes, because each of these sub-boxes use the radial function, then you take the average of all 100 to get the average of the box. That's not weighted. That's just like a straight up average. So it's the temperatures, all 100 of them added up, divided by 100.
Right, because the weighting has already happened in the smaller boxes. So you don't have to weight them again for the bigger boxes. Okay.
Yeah. So the part of the process where we're using the weighting function to get the sub-box temperatures, that's often referred to as the interpolation step. And then when we start averaging to combine those sub-boxes into the 80 boxes, now we're moving into what's called the averaging step.
And what do we do with the 80 boxes?
So once you have the boxes, you calculate the latitude bands, and then you calculate the global based on the area. Even though the boxes have the same area, the bands do not have equal area. So when you average based on band and then you combine for global, you're going to weight based on area that the band covers.
Right, because we're dividing something that's a sphere into boxes that we need to measure.
Boxes,
so
yeah.
There has to be more weighting to account for the places that are at the poles versus at the equator, etc.
Yeah.
Okay, so essentially we have a lot of boxes. We measure things in them. We weight it to be the most accurate it can be. And then we end up with our 1.5 degrees.
Yeah, or then we end up with the temperature of the Earth.
Yes.
So that's really how we get to the average temperature. But I think it's also important to remember that this is an average. And so not everyone is going to experience the same temperature change. There will be countries that experience more and countries that experience less. So I kind of put in this graph, and I pulled this one from the IPCC report to kind of show like which countries, for example, are experiencing more temperature change than others.
What we're seeing is kind of the same pattern that we've seen for a while and that scientists have expected and investigated, that we're seeing greater changes in temperature at the extremes. So at the poles, we're seeing a greater change in temperature than other areas. In some areas of Canada, already in the Arctic, I believe they've actually already hit or surpassed 1.5 degrees of warming.
Yeah. This will not be uncommon because 1.5 degrees is the average. That means that there will be quite a few countries above and quite a few countries below.
And I think what's interesting along with that, too, is the temperature. As much as it is like an effect, it can also be a cause. For example, ice in the Arctic melts, it raises sea levels, and then countries that are islands, for example, especially island communities, that maybe they didn't experience more than 1.5 degrees of warming as in the north, but what they might be experiencing and what they really are experiencing now that we've seen is rising sea levels are leading to more erosion, and some island communities are at risk of being lost entirely.
Yes. What we're seeing is that there will be populations more vulnerable than others.
And I think that's also what leads to some confusion among the general public about climate change happening, because really what it means is, as an average that we've talked about, you have that warming, but at a local level, that can lead to more extreme weather events that go either way on the temperature scale, right? So we can experience more severe cold snaps in some areas than previously, or, more proliferative dumps of snow. But in other areas, it's going to be the opposite. And
so you're going to see heat waves, for example.
And I think that kind of leads nicely into the next section of what we wanted to talk about, which is, what does the world look like with an average of 1.5 degrees of warming?
Yes.
Before we launch into it, how do you feel envisioning the 1.5 degrees of warming world?
It doesn't fill me with rainbows and unicorns.
Yeah, if we were Marie Kondoing topics, this one does not spark joy.
Yeah, I mean, when I think about the world, if it warms to 1.5 degrees over what it is, or if more, I think that means that there will already be a lot of suffering in vulnerable communities and in communities where temperatures increased even more than the 1.5 degrees.
Yeah.
I guess what I'm trying to say is, I think we think about climate change sometimes as not being here yet, or global warming as something that hasn't happened yet, and we're not seeing its effects quite yet. But really we are. And now it's no longer a matter of can we prevent it, but what are we going to do to address it? And keeping temperature or keeping global warming at 1.5 degrees is really the decision we've made to address climate change and global warming. But it's not going to prevent it. So we're already going to see losses.
It leads to that conversation that I think is really exemplified in a book I know we've both read and loved, which is All We Can Save, which is an anthology of essays and poems about the climate crisis. But, the title kind of says it all, is we're trying to figure out what we can still save.
Yeah, what can we save? It's no longer a question of can it be saved? It's what are we going to save?
Yeah. And that really leads into, what does it look like? The Intergovernmental Panel on Climate Change releases reports. Their most recent one was in 2021, and then there's been updates since then to that report about what the current state of climate change is. A lot of what is coming out with the IPCC reports hasn't changed a ton in the last few years. Just the level of evidence for it has increased.
And I think what we're seeing with monitoring the temperature of the Earth says a similar story. Even though we've gotten more meteorological stations to monitor temperature, and we figured out how to monitor temperature over the ocean surface and how to correct in urban communities or urban boxes, the trends are still the same, that temperature is rising.
Yeah. And to kind of provide an overview of what a 1.5 degree world looks like and what a 2 degree world looks like, there's a fantastic article published on NASA's website called A Degree of Concern, and it's written by Alan Buis in 2019. So these figures would be from the 2019 report, but I went through the 2022 report to see if anything had changed. Really, a point of emphasis is that what we've been talking about is there's no single 1.5 degree warmer world. It's not spread evenly, and it's not spread evenly now nor in the future. There's a few principles that it follows. So warming is often higher over land than over the ocean. And right now, the strongest warming is happening in the Arctic during cold seasons and in the mid-latitude regions during warmer seasons. And we've hinted a bit that some areas have already surpassed 1.5 degrees. And the reality is more than 20 to 40% of all humans actually currently live in regions that have already seen warmer greater than 1.5 degrees Celsius in at least one season.
So in many ways, we're already experiencing 1.5 degrees of Celsius warming.
Yeah, at least in some seasons.
This reminds me, I think it was in November, I was reading an article, but there was a doctor who diagnosed his patient, like the diagnosis he gave was climate change, because I think it was something related to heat stroke.
Oh, yeah, there's been a lot of conversations about what you actually write on the death certificate. This became a big problem in BC. There was a heat dome, July 2021.
Okay.
And it led to hundreds of deaths, especially in the lower mainland, because they haven't had to have AC.
Because it's so temperate.
Yeah, and it's often pretty rainy. Like, it's not uncommon in the summer, well, back in the day, for temperatures in, Vancouver to be kind of mid-20s in the heat of the summer. Like, you might need to wear a jacket at some times. And so there was this whole conversation about, yes, a lot of these people died of heat stroke, but what they really died of was climate change. So what do you put, as the cause of death?
Mm-hmm. I feel like at times it's very sobering, and I feel very small. I know that we should all be working towards addressing the climate crisis, but it just feels like such a large problem. It feels like bigger than something my one brain can handle. I guess a lot of us are already experiencing what it will be like with 1.5 degrees of warming, at least in one season, it seems, or in some seasons.
Yeah, exactly. And it's all connected, right? Because, let's look at BC. So there was a heat dome.
Mm-hmm.
And then things were tinder dry.
Yes.
And
then you got forest fires.
Yes, and an entire town burnt down. I'm referring to Lytton, BC. And then one of the issues with fires is a lot of trees die, air pollution, but it creates very unstable soil.
Okay.
And then we had what they called an atmospheric river. There's all these new weather things that maybe they've existed for a long time, but I've never heard of them before. And all of a sudden it's, you have the heat dome and then you have the atmospheric river and just crazy amounts of rain fell, which washed away
the Coquihalla.
The Coquihalla, the main highway that connects the coast to the rest of Canada.
I feel like I'm with you. I wish I lived in a time where I didn't need to know what a heat dome was.
Yeah, I've seen people say before, I'm getting really tired of living in unprecedented times.
Yeah. So I guess we talked a little bit about BC and some of the things that you're seeing there, but are there I know that there are other effects that we will see across the world. Do we want to give a little bit of an overview?
Absolutely. So BC is kind of a nice case study, and we're well familiar with it as Canadians. But it's something that will pretty much any natural disaster you can think of. The frequency, intensity, the prediction is that that's going to increase with climate change. And we've already seen that in a lot of places, right? So hurricanes are an example. It always seems like the next hurricane is, the craziest intensity that we've seen before.
Yes, I used to wonder when I heard those reports, I was like, is it because we're just getting better at measuring and monitoring hurricanes, or is it because they are actually becoming more extreme?
Yeah, so I think at some point there were improvements in measurement. I did a project looking at 100 years of earthquake data along the San Andreas Fault.
Okay.
And I found that over 100 years, the number of earthquakes increased, but it's because my data went back to the 1900s and then in the 2000s, right?
Yeah.
Our ability to measure earthquakes really increased. And so there would be that same change, but not to the degree that we've seen recently.
Yeah. So it's really, I guess, the pace perhaps and the extremeness of the hurricanes that we're seeing.
Yeah, exactly. And same with flooding, right? So flooding's maybe a bit easier to measure than hurricanes, but we're seeing that as well more commonly for a variety of reasons, it's connected to other natural disasters.
Yeah, so I imagine that as temperature rise, glaciers melt, water levels rise, you're at more risk of flooding.
We've talked a bit about kind of the natural disasters we can anticipate.
I guess, do we want to put some numbers to it maybe?
Yeah, let's put some numbers to it. Okay, so for temperature, if we hit 1.5 degrees warming globally, 14% of the world's population will be exposed to severe heat waves at least once every 5 years.
Okay.
At 2 degrees, that number goes up to 37%.
Okay. So more heat waves.
More heat waves, absolutely. The most extreme warm temperatures will be in Central and Eastern North America, Central and South Europe, the Mediterranean, Western and Central Asia, and Southern Africa.
Okay.
For droughts, if warming reaches 2 degrees, 61 million more people in urban areas will be exposed to severe drought than if we kept it to 1.5 degrees.
All right. That's a lot of people.
Yeah. For water availability, if we can keep it to 1.5 degrees as opposed to 2 degrees of warming, 50% fewer people on Earth will see climate change-induced water stress. There's a lot at stake with keeping it to 1.5 degrees.
And when you say like water stress, you mean like access to clean water or like potable water?
So we can talk a bit more about the ocean. If we hit 2 degrees of warming globally, more than 70% of coastlines are going to see a rise of greater than 0.2 meters, which is like 20 centimeters.
Okay.
So more coastal flooding, more beach erosion, and more salinization or like saltiness in our freshwater supplies.
I don't know. That makes me quite sad for like places in Canada like PEI, which is like an island.
The Antarctic ice sheet and the Greenland ice sheet, the instabilities and losses that we'll see with climate change could lead to a greater than 6-foot rise in sea level over the next, they're not sure if it's hundreds or thousands of years, but 6 feet is a lot. It's taller than me.
Yeah. Taller than me too. What's all this going to mean for us?
For humans?
Yeah.
We've already talked a little bit about it. So heat-related illness and mortality is going to increase.
Okay. Because of increased heat waves.
Yes, exactly. And it could get more expensive to cool. Another part of it is vector-borne diseases. So diseases that are carried by mosquitoes, for example.
Or I guess ticks as well.
Yes. Ranges could expand for the insects and arthropods that carry those. So malaria and dengue, West Nile virus could increase as well, like depending on how the range is, because there's temperatures and humidities that these insects like to live in.
Okay.
And so as our climate changes, the areas that are habitable to these insects could expand.
And then obviously that will put strain on healthcare systems,
which are probably already strained from heat-related illness and mortality and pandemics. Food security is the one that is concerning. Well, they're all concerning, but especially concerning. So at 2 degrees, we're going to lose 7 to 10% of rangeland livestock globally.
If we lose 7 to 10% of rangeland livestock, we might not be able to feed everyone.
Yeah.
Like we already struggle to feed everyone currently.
Yeah. And what I think one of the biggest struggles is allocation of food resources. Like there's so much waste, food waste in developed countries and, so much need in other areas. It'll just exacerbate the people that are most vulnerable to begin with.
Yes. So now we've talked about how we calculate the Earth's temperature. We've talked about some of the things to expect at 1.5 and 2 degrees of warming of the Earth. But where are we currently sitting is what I'm wondering. Because I know that we've been passing a lot of policy surrounding climate change.
So,
okay. The tone of your voice does not give me much confidence, but we shall proceed.
Trying to put on a brave front here. 1.5 degrees is becoming less and less likely.
Okay.
Especially because we've already hit it in so many areas. There was a paper published in Nature. It's titled Realization of Paris Agreement Pledges May Limit Warming Just Below 2 degrees Celsius. What this study did is they looked at the Glasgow Climate Pact, which came out of the 2021 United Nations Climate Change Conference, which has been referred to as COP26. And what they did is they quantified the pledges from COP26 and ran the math to see, what's our chance of keeping it below 2 degrees?
Yeah.
And it's less than 50%.
So keeping it below 2 degrees, we have less than 50% chance.
Yeah, that's their prediction. But it's not completely hopeless.
Okay.
So we can keep warming below 2 degrees Celsius if all conditional and unconditional pledges from the Paris Agreement, from the Glasgow Climate Pact, etc., are fully implemented on time. So that would keep us around 1.9 to 2.
Okay.
But the confidence interval on that was very wide. So it went up to 4, I believe.
All right.
And if we want to keep warming now well below 2 degrees, we urgently need policies and actions to bring about, a really quick drop in emissions.
Mm-hmm.
So we're looking at passing median warming of 1.5 degrees just after 2030, even if the most ambitious emission pledges we currently have are met.
So that world that you were describing seems like something we'll have to prepare for.
Based on the best available data at the time, it's coming, and in many places it's already here.
Okay.
On a side note, we will have climate anxiety resources in our show notes.
Yes.
Because it's a lot to take in, but I think it's important to have an understanding of the numbers and the data, because we can't solve a problem we don't understand the scope of, and we don't know where we're at in.
Yes. And I think sometimes we haven't taken action on climate change as the humans, because we're we don't have enough data. We don't know what's happening. But I think now we are confident that global warming is here. We track it effectively. We have measurement systems that we know are accurate and in place, and we should begin to address it, or we should start addressing it with zeal.
Yes, the time is now. There's no time like the present. I think this leads very nicely into our science seed for the day.
Yes.
Which is a little bit of a call to action. Each episode, we like to give our listeners something to think about, a science nugget to help you think more critically about the numbers, statistics, science, and currently calls to action that you might hear about every day. Lev, do you want to introduce us to our science seed?
For sure. Climate change and global warming and all of these things that are happening around us can feel very sobering, and you can feel like you don't really have much of an impact and you don't know what to do. It can create inaction because you're scared, or at least that's how I feel sometimes, because I have no idea what to do, but I know it's happening around me, and I don't know if what I am doing is making a difference, so in many cases I do nothing.
It's almost a fight or flight response, and you freeze.
Yes, it can be. What I wanted to leave our listeners with today is this exercise that was developed by Dr. Ayanna Elizabeth Johnson to help you determine what are some things that you should do to help address the climate crisis. It's a Venn diagram, so it's 3 interlocking circles. In the first circle, you put what brings you joy. And in the second circle, you put what are you good at. And in the third, you put what is the work that needs doing. And then the intersection of all those things is what you can do to help address the climate crisis.
I think that's perfect because we all have different talents and gifts to share and different passions and causes that move us. And when we put those together with what needs to be done, I think that gives us the best chance of doing the work.
It's also a good antidote to that freezing feeling. You'll see what it is that you can do, I hope. Thanks for listening, everyone. You can find us on Apple Podcasts, Spotify, Google Play, or wherever you find your podcasts. You can find the references we use for this episode in our show notes. A special thank you to Julian Bertino, who does our sound editing and music.
If you have a moment, please rate and review us on Apple Podcasts and Spotify. It really helps our podcast reach new listeners. Have an idea of what number we should cover next? Want to learn more about what we talked about today? Follow us on Instagram at The Secret Life of Numbers.
We'll catch you next time on The Secret Life of Numbers, where the numbers can run,
but they can't hide.